Hey guys, here we have a June exam paper. I don't know why it doesn't say here June, but it's a June exam paper from it's Maths Paper 1. It's also grade 12, and it's from 2021, 150 marks, 3 hours. If you want to download the paper, check the description below. Solve for x. Right, so this first one over here that they typically give you in the beginning of an exam can typically be factorized without having to use the quadratic formula. It's only really this one and the second question where they say correct to 2 decimal places. That's where you have to use a quadratic formula, because the fact that they're saying that means that it cannot be factorized. So for this one over here, remember that this is a -1. So you look at the number 20 and you think about all the different ways that you could make 20. You could say 1 times 20, 10 times 2, 5 times 4. Now, you got to look at which of these combinations can make -1. Well, it would be 5 and 4, because if I say 4 minus 5, what does that give me? -1, and that's exactly what we want there. So what we'll do in an exam is you would write it down, then you would make your 2 brackets, and you would say x plus 4 minus 5, because the 4 is a positive and the 5 is a negative. Okay, and now you're just going to say x plus 4 equals to 0, or x take away 5 equals to 0. Therefore, x is -4, or x is 5. Now let's go to this next one. The next one says, okay, I'm going to leave some of that in case some of you are still writing that down. Okay, so let's look at this one. Now, because they say correct to 2 decimal places, we have to use the quadratic formula. That is always going to be given to you on a formula sheet, but I'll just write it down. Now, I want you to get into the habit of always putting, especially if the b value is a negative, you must put it in a bracket for this part over here. Here you can as well, but it's very important that you do it over there. Okay. So all that they want to see in an exam is that you fill in the correct values. So remember, this is your A, this is your B, and this is your C. So the formula starts with a negative. So we put the negative, then B is -2. So you can do it like that, or you can put it in a bracket. It's up to you. And then you're going to have a plus minus. Then you're going to fill in B. Now when it's a negative especially, please put it in a bracket, because if you just fill it in like that, you're going to get problems. So rather put it in a bracket like that. And then A is 3, C is -6. At the bottom is 2 times A, which is 2 times 3. Right, now you can just go fill it in on the calculator like that. In one of the moments, you're going to make it a positive on your calculator, and then in the next one, you're going to make it a negative. You can't do positive and negative at the same time. So you can then go get your answers, and you should get 2 answers. First answer is 1.79, because remember we have to round it to 2 decimal places, or the next answer would be -1.12. Here they want us to solve this inequality. There's multiple ways you can do this depending on your level of understanding. I think the easiest for most learners is going to be to multiply this out. Now remember, when they have a 2 here, it means we can make 2 brackets, and then if we multiply that out, you'd end up with this. And so then I'm just going to simplify, take everything to the one side, so that's going to become -2x. Then we're going to have +1 minus 9, and then +1 minus 9 is -8. Okay, now we need to solve this. So what I want you to do is I want you to pretend that this was an equal sign. Okay, so you can just do a little side calculation over here. And we're going to go calculate your critical values. They even call it that on the memo. Okay, it's not just something that I've made up. So what you're then going to go do is just factorize this normally. So that would be x minus 4, x plus 2. So your critical values will be x equals 4 or x equals -2. Now some learners, they just like, oh, okay, so I can just change this to this, and there's my answers. Nope. Don't do that. What those numbers are now is you can make a number line and you can fill them in. -2 is on the left because it's smaller than 4. Now there's multiple ways that I've showed how to do this, multiple ways your teacher would have showed, but one of the basic ways is I go back to this most recent simplified step over here, and I ask myself, I know that this is a parabola, But I ask myself, is it a happy or a sad parabola? Well, it's a happy parabola because this number in front of the x squared is positive. Positive, smiley face. Positive people are happy. If it was a negative in front of the x squared, then it'll be a sad face. Sad people, negative. Happy, positive, sad, negative. You see how you can think about that? So it's going to be a happy parabola. So I draw a happy parabola, just going like that. Now, the next thing I look at is, it says, where is this happy parabola bigger than 0? So it means, where is it above the x-axis? Because when it says, if a function is bigger than 0, that means above x-axis. If it said like that, then it means below x-axis. So where is it above the x-axis? Well, that would be this area, and it would be this area. So in interval notation, you could say that x is an element from negative infinity up to negative 2. We're not going to include the negative 2 because they haven't included anything. And then we're going to say or, and then we could say 4 to infinity. Okay? If you use in set border notation, you could say that x must be smaller than negative 2 or x must be bigger than 4. Now I know that earlier on when I said here that some learners, they just do this and they just do this. This part would have been correct, but this part would have been incorrect. You see, that's the problem. So don't confuse your critical values when you get your answer. Here we have a square root equation. All that you want to do is get your square root and any number in the front of it. You can get that all together. So we want to take this 2 over to the other side. So we take it to the other side and it becomes a negative 2. So what you now do is you square both sides. Square and square. So remember that the square of 2 is 4. The square of this, all that does is it just takes the square root away. So just you're left with x plus 6. Like that. Now here a lot of learners, they just put the 2 there and they just put the 2 there. Just like what we did here. But on this side, this is one term. Whereas here, we've got 2 terms. So put 2 brackets instead. And so if we multiply this out, we end up with 4x plus 24. Here you would end up with x squared, take away 2x, add 4. Now it's just a trinomial that you can move however you want. I'm going to move everything to the right hand side. And so it end up with minus 2x, minus 4x when this one comes over. Then plus 4, minus 24. And so we end up with minus 8x if you put all of those 3 together. And then minus 20. You could use quadratic here, but I can see that this one will actually factorize as using a 10 and a 2 because that gives you 20. But we could also make minus 8 by saying minus 10 plus 2. And so if we had to go and solve this, you would say x minus 10 is equal to 0 or x plus 2 is equal to 0. Therefore, x is 10 or x equals negative 2. Now, that'll get you 3 out of 4 marks. Remember that when we have a square root, I want you to take these 2 answers and do a check. That'll get you your 4th mark. Okay, so we're going to go do a check, and all that means is you take the first value and just go plug it into the left-hand side. So let's check with x is 10. Plug it into the left-hand side of that equation. So that would be 2, 10 plus 6. Plus 2. And if you had to go work that out, that would give you 10. And then if you work out what is the right hand side, well, you would just plug in x is 10. And so because the left and the right are the same, that's a perfect solution. It's got nothing to do with the fact that the answer was also 10. That's just a coincidence. Now we're going to go check the other one. Now this one, the second, or there's always one that usually has a bit of a problem. So now we're going to let x equal to negative 2. So on the left-hand side of this equation, you're just going to go plug in negative 2. So that'll be 2 minus 2 plus 6 plus 2. And that'll give us 6. Now, if you had to go plug that in on the right-hand side, well, you would just be plugging in there. And so your left side and your right side are not the same, so this one would be not applicable, and so your only answer would be 10. Solve simultaneously for x and y. All you do in these questions is, okay, let's label this as equation 1, let's label this as equation 2. Take the easiest looking equation, which is this one, and get x or y by itself. Here we already have a y, so let's get that by itself. The way to do that is just take the 4x to the other side, and then label this as a new equation, number 3. What you then do is you put or substitute equation 3 in equation 2. So what that means is you're going to take this y, which is that, and you're going to put it over there. So you're going to end up with 4x plus 2 take away 4x squared, because there's a 2 there, equals 8, and now you just solve. So make 2 brackets, and then 4x plus, now you're just going to go multiply those brackets out, minus 8x plus 16x squared. I'm going to bring everything to the left, so that's 16x squared. This will be minus 16, and minus 16 plus 4 is minus 12, and then here we're going to have plus 4. I'm going to bring this 8 over, so it'll be 4 minus 8, which is minus 4, equals to 0. You can solve this however you like. Quadratic formula, you could divide everything by 4 first. I'm just going to go straight to the quadratic formula. X equals minus b plus minus this. Fill everything in, so this is your b, this is your a, and this is your c. So it's going to be minus 12. Put the b in a bracket when you're using this part here with the square. Minus 4, a is 16, and c is negative 4. Okay, and then at the bottom we have 2 times a, which is 16. Okay, let's go get our 2 answers. So x would be 1, or x would be negative a quarter. So now we need to go get the y values. So you just come back to equation number 3, because it already has the y value by itself. So to find the first y value, you just plug your first x value in. So we can just go y equals to 2 take away 4 multiplied by 1, which would be negative 2. So there's your first y answer. And then you just do it again, but now you just use, oh, what happened there? Use negative a quarter. So that's going to be 2, where's my equation? Oh, there, minus 4, and now we use minus a quarter, and that'll end up giving us 3. Haha, the famous 1.3. So 1.3s can always be a little bit weird. I don't want you to waste too much time on these in the exams, especially if you're a student that gets like 40s, 50s, 60%. You don't need to get this question. Try it, see how it goes, but it's only 4 marks, so it shouldn't take you too long. Okay, shouldn't take you more than about 6 minutes. So how did I work out 6 minutes, by the way? Well, these exams are usually around 180 minutes, 3 hours, and they're usually 150 marks. So to work out your minutes that you should spend per mark, you just divide those 2 numbers, and it'll give you 1.2. If you then say 1.2 multiplied by 4, it'll give you 4.8. Okay, I don't know where I got 6 from. That's a bit awkward. 4.8 minutes, which is like 4 minutes and 48 seconds. Okay, so if it is given that this is equal to this, determine the numerical value of x minus y. Okay, in these types of situations where you've got 2 unknowns, we know that it's technically impossible to solve an equation when you only have 1 equation but 2 unknowns. But when they do this in an exam, then there is actually only one specific answer, and so it can actually work. All I want you to do is just do something like this. Break this number down using the prime fact technique on your calculator. You know, when you break it into prime numbers, however you like to do that, you should end up with 2 to the 3 and 3 to the 1 technically. And then there's a 6 on the outside. Now, if we use exponent rules, we know that we should multiply that number and we should multiply that number. So we're going to end up with this, 18, because 6 times 3 is 18, and then 1 times 6 is just going to be 6. Now, when they give you these kinds of scenarios where you only have one equation but two unknowns, then I just want you to say that this part must be the same as this part, and then this part must be the same as this part. And so for this first part, if you cancel the 2's, then x is simply 18. And then for this part, if you cancel the 3's, then y must be 6. Now they said, what is x minus y? So that's going to be 18 take away 6, which is 12. So it says, consider the quadratic sequence and determine the nth term. Okay, so that for you guys should be a very easy question, but I'm going to give you a quick little summary. We know that we get three main types of patterns. We get quadratic, we get arithmetic, and then we get geometric. Okay, and so we know that the quadratic is when you have Tn equals to an squared plus bn plus c. Arithmetic is when you have a plus n minus 1 times d, and then the geometric one is the ar to the power of n minus 1. Okay, so those are the three main patterns that we know about. This one is quadratic. Okay, so if I look at this quadratic pattern, I'm just going to write it down quickly. Let's ignore, I don't want us to get confused with this pattern over here. I'm just going to block that out a little bit, just so we can remember there is a pattern there for later on. Okay, so if we go write out the pattern, it's going to be 72, then it's 100, then it's 120, and then it's 132. Then if I look at the difference from here to here, it's just going to be 28. I'm going to go quite quick because you guys probably know this quite well. And then this would be not 32, 12. It would be 12. Okay. And so what we can now see is that there is a common difference going into the second pattern, and that's -8 and then -8. So that is what a quadratic number pattern is. It's when the second difference remains constant. Okay. Now, there are three different formulas that you need to remember for these quadratic patterns. So what you're going to do is you are going to circle, or you're going to put a little block around the first numbers. And then we're going to use the following formulas. 2a for this one, 3a plus b for this one, and then a plus b plus c for this one. Okay, your teacher might do that part differently, but that's fine as long as we get to the same answer at the end. Right, so what we do is we start at the bottom. So 2a is equal to -8, and so that means that a is -4. And then let's move on to the next one. So now we say 3a plus b is equal to 28, but now we already know that a is -4. And so if you had to go work out b, I'm going to move quite quickly. B should be equal to 40. And then if we go work out a plus b plus c, that should be equal to 72. But now we already know that a is -4, b is 40, and then plus c. And then if you had to work out c, we should get a value of 36. So c would be 36. Okay, so for most of you, as I said, that's fairly easy. So the formula is going to be -4 n squared plus, where's b, 40 plus 36. Okay, and I'm just going to check it quickly. I always like to check it just to make sure we haven't made any small mistakes. Yeah, it works. Okay, so there we have it, guys. I'm just going to erase all of this now. Right, 2.1.2. A term in the quadratic sequence is equal to the 12th, I nearly said 12th. It's a difficult word, 12th. 12th term of the sequence in the first differences. Okay, determine the position of this term in the quadratic sequence. Okay, so what we must remember is that this row over here is called the second differences. This row here is called the first differences. So they said that a certain term in the quadratic sequence, which is this one, so let's call this one the quadratic, is equal to the 12th term of the sequence in the first differences. So what we're going to do is we are going to take this pattern over here, and we are going to look for the 12th term. Okay, We're going to look for the 12th. Try to say the word 12th. I don't know. I find it very difficult. I don't like that word at all. I'm going to say the 12th. There we go. I'm not going to say the F. 12th. Okay, so the 12th term. And so if you look at that one carefully, you should identify that that is arithmetic. That's an arithmetic pattern, that one that I've highlighted in green. Okay, so we know that the formula of an arithmetic pattern just goes like this. Okay, some of you might have used a formula like that, but that was in grade 11. So most of you are now going to be using this formula that I've just shown, and they would like us to find the 12th term. So term 12 in that pattern is equal to A. Now remember that A is term 1, but that's in this sequence, so that's going to be 28, term 12. Now your common difference as you go from one term to the next is going to be minus 8. Go ahead, type this in on your calculator, and that gives us negative 60. So we've just found the 12th term as minus 60. Okay, so they said that a certain term in the quadratic pattern, now remember this is the quadratic pattern over here, a certain term there is equal to the 12th term in the first differences. So that's equal to negative 60. So we need to see which term in this sequence is going to have a value of negative 60. Okay, that is pretty much what we are trying to do now. And so what I'm going to do is come back to this formula, and we are going to try find term number, or we're going to try find which term is equal to negative 60. So I'm going to start off by saying negative 60 is equal to negative 4n squared plus 40n plus 36. Okay, so if we go plug this now into if we go plug it into the equation now, it is going to be, okay, we get an answer of 12. That looks better. Or n equals to negative 2. But now you can't have a negative n value because that's the position number. And so that means that n is going to be equal to 12. Okay, and so that's the end of that question. This next question says, determine the maximum value of the quadratic sequence. Now, we can approach this from a grade 11 perspective or from a grade 12 perspective. I'll show you both because some of you still prefer the grade 11 perspective. Okay, so if we look at this equation, if that was a graph, it would be a parabola because a parabola always has an x squared, and it would be a sad parabola because it's got a negative. So we know that this graph is going to look something like that. Okay, and so it definitely has a maximum point or a maximum value. So in grade 11, you can use minus b over 2a. Okay, if you want to take it from a grade 12 perspective, we know that to find a turning point, you make the first derivative equal to 0. So I'm going to use, it doesn't really matter. To be honest, it's actually the same thing. I think I'm going to use the grade 12 approach. It doesn't really matter. So I'm going to take the first, actually, no, I'll use the grade 11 approach. So I'm going to use minus b over 2a. So we'll go n equals to minus b over 2a. And so that's going to be minus 40 over 2 times negative 4. And that should give us 5. 40 divided by 8. Yep, that's 5. Now, is that the answer? No, of course not. What that is just telling us which position we are at. So you see, this is position 1, this is position 2, position 3, position 4. They are telling us that the maximum value is at position number 5. So to determine the actual value, you're just going to plug 5 into the equation. You're just going to plug 5 into the equation, which is this equation over here. And so if we go plug in term 5, so term 5 is going to be minus 4 in brackets, put the 5. Okay, and that should be, what is that? 236, 136. Let me see. Yes, 136, 136. Okay, so that's the maximum value in the sequence. So that means that this is position number 5, and it has a value of 136. Oh, now we're moving on to a totally different sequence. It says determine the maximum value of that sequence.
Okay, it's a pretty random question for only 1 mark. This better not be something funny. I feel like something weird's about to happen. Okay, so if we look here, the common difference there is 28. Then the common difference there is 20. And then the common difference is 12. Okay. Okay, I see there's something familiar here. Just wait. 72, 100. I remember seeing those numbers. Don't know if you guys can remember. There we go. 28, 20, and 12. Okay, this one's quite easy actually. Check here, guys. It's quite silly. If this pattern just keeps going on, then we're gonna mind this is gonna plus 4, so that would go to 41. And then you're just gonna, yeah, this is a silly one. Then this would become minus 4, so this would become 37. So what is the maximum value? Well, the maximum value would be here at 41. Can you see that? A lot of students in the past, and they always like freak out when they go into exam and it's a paper 1 exam, and then they come back after the test and they're like, sir, they had paper 2 content. Why are they doing this to us? Guys, they are sometimes going to do that. But it's usually not going to be that difficult. They're just putting in a little bit of paper 2 work in the paper 1 work. It can happen, okay? So don't be surprised when it happens. It can happen, and it probably will happen. So it says here, consider the sequence, and then they give us the first 3 numbers. Then it says, determine the values of x for which the sequence is arithmetic. Now, we know that when they ask a question like this, it normally looks like this. They'll do something like 2x minus 8, and then 3x plus 6. And then they'll say, find the values of x if this sequence is arithmetic. Then we should always say that term 2 minus term 1 is equal to term 3 minus term 2. That is what we would normally do in order to determine x if it is or arithmetic. Here they have told us that it is or arithmetic, so I'm going to use the same approach, and let's see how that goes. So we're going to say term 2 minus term 1 must be the same as term 3 minus term 2. That's because it's arithmetic. So term 2 is going to be 2 sin 3x minus term 1, which is minus 11, and that's equal to term 3 minus term 2. Okay, just going to simplify this a little bit. Guys, mustn't panic if you see something like this. Just go with it. So what we can do is take the minus 2 sin 3 to the left. And so that's going to become positive. So we're going to end up with 4 sin 3x. And then on the other side, we're going to have 15 minus 11, which is 4. Then we can divide by 4. So we end up with sin 3x equals to 1. And now all of a sudden, we have entered the area of general solution, specific solution, the one where you have to get your reference angles and all of that stuff. Well, that is what we now have to do. Now, there are 2 different methods that we could use right now, and I don't want to confuse anyone. So some of you, and this is how I teach some of my personal or private students, whenever they give you a sin or a cos, and they make it equal to either a 1, a 0, or a minus 1, I don't like to solve that using reference angles. I rather solve that using the graph, because if I draw a sin graph, then it's very easy to see where the graph is supposed to be equal to 1. It's supposed to be equal to 1 over there, okay? But then there's other students that would maybe like to use the reference angle approach, okay? So yeah, there's 2 different methods. Let me quickly, in fact, let me do both, because I know that there's 2 different types of students who are watching this. Well, there's more than 2 of you, but 2 groups of students. Okay, so for the first method, I'm just going to draw the graph. And it's a normal sin graph. Yes, I know there's a 3x there, but we'll fix that up just now. Okay, so I know that the sin graph is equal to 1 at 90 degrees over here. And then I know that that will probably repeat again over here. And so that means we are repeating every 360 degrees. That's how often it repeats. So I could now say that 3x is equal to, and I'm going to use the other method now. So if you're feeling a bit confused, I'll show you another method now, is equal to the first angle, which is 90. And then I say plus k times 360, k is an element of z. Your teacher might use an n over there. That's okay. I used to use n as well. It doesn't really matter. Use whatever you're comfortable with. Then we can divide by 3, and so that's going to give us 30 degrees plus k times 120. K is an element of z. And so that's literally the answer. So they said, find all the values of x in the interval of 0 to 90. So that means that if I make k equal to 0, then that means x will give me 30. And if I make x equal to 1, if I make k equal to 1, then I'm probably going to get an answer that's too big, because that gives me 150. And that is too big because they only want the answers between 0 and 90. Okay. Right. So now if you prefer not to use the graph, I know some students don't even know about the graph method. Maybe your teacher hasn't done that one with you. So then what you guys would do, so let me quickly say here that this is a alternative approach. Geez, I'm glad I'm not an English teacher. Alternative approach. So what you would do is you would say sin 3x is equal to 1. And then you would go get the reference angle on your calculator. So the reference angle would be when you say sin minus 1 on your calculator of 1, and that would give you 90 degrees. And then you would say that sin is positive in quadrant number 1 and quadrant number 2. So quadrant number 1, and then I'll do quadrant number 2 over here. So for quadrant number 1, you would say that 3x is equal to 90 plus k times 360. And so x would be equal to 30 plus k times 120. And then for quadrant number 2, then you would say that 3x is equal to 180 minus the reference angle. And so that would give you 3x is equal to 90 plus k times 360. You see how we're getting the same answers, guys? And that is why I don't really like using this method, because it's very repetitive. You see we're getting that as the same and that as the same. So I like to use the graph method, but this method does work. And so we're going to end up with 30 plus k times 120. So we're getting a bit of a repetition happening. So the final answer for this question is literally only going to be x equals to 30.
If R is 1 over 5 and A is 2000, determine Tn. Okay, so that's a pretty straightforward one. We know that it's going to be geometric because they're giving us the R, so we're going to go AR to the power of n minus 1. So Tn will just be A, which is 2000. R is 1 over 5. N minus 1. Never multiply these two numbers together. You cannot do that. Why? Because this to the 1 over 5 has an exponent, so you can't multiply these. So that is your answer. Now it says determine T7. So that's literally just going to be plugging in 7 as your n value. And so if you go work that out, you end up with 16 over 125. Or you could also write it at 0.128. It's always a bit awkward, or a bit weird. There's a bit of a gray area because technically we're supposed to give our answers with 2 decimal places, but with questions like this on the memos, they'll actually leave it as a fraction. Or if they do the decimal, they won't round it off. It's quite interesting, but what you'll notice is that with these kind of answers, the decimals, they stop. They don't like go on and on and on. So there's a bit of a gray area there. I can't give you an exact suggestion, but like I just knew from experience that I wouldn't round off. And then I looked on the memo and it's exactly the same. So whenever you're doing these kind of questions and you get like a fraction answer, I would probably leave it as a fraction. Okay. Next one, which term will have, but I think if you did have to round this off, it wouldn't cause any issues. They won't mark that wrong or anything like that. So let's move on to this one. Which term will have a value? So this is now where students get confused. When they say which term will have a value, then I want you to take that and put it there, okay? And so that's going to be 16 over 15625 equals to A, which is 2000, 1 over 5, and now we don't know the term, so we say n minus 1. Okay, so we're eventually going to have to get this, so we're probably going to have to use logs, or we can use the prime fact kind of method. So let's just see. We're going to divide, we need to get rid of that 2000, so we're going to take this and divide it by 2000. So that'll give us, divide by 2000, and that'll give us 1 over 1953125, and then this is 1 over 5 to the n minus 1. You can use logs right now, or you can use the prime fact method. Let me show you both. I'll show you both techniques. So let's use logs first. Logs method, prime fact method, which we learned in earlier grades. Okay, so with log, you're going to have 1 over 1953125 equals to 1 over 5 to the n minus 1. So with log, the exponent becomes equal to log. Now this is the base, so you'll keep it as the base in your log, and then this number will go here. Okay, and then you can actually, and then take this minus 1, and it can go over to the other side like this. But now some learners make the mistake, they put the plus 1 inside the log. It's not in the log. The log ends over here, and then it's a plus 1. Okay, and so if you had to work this out, some learners struggle to find the log on their calculator. There are 2 logs on a Casio calculator, by the way. Just under the on button is the one you want to use. The other one is very close to that one. You just go down one more button and then to the left. You don't want to use that one because that one doesn't have a base. So you want to use the one that is under the on button. Okay, 1953125, and then put the plus 1 outside the log bracket, okay? And you should get an answer of 10. If you use the prime fact method, then you would, let's just quickly do this. This one doesn't always work if the answer is not a whole number, but in this case it is. Okay, so you're going to take this number and you're going to say, you're going to type it on your calculator, you're going to press equals, and then you're going to do the shift fact to break it down, and that's going to give you 5 to the 9. Okay, now if I bring this up to the top, okay, then it's going to be, there are other ways of doing this, but I think the easiest to understand is if I take that to the top, it becomes 5 to the negative 9. And if I bring this one to the top, it becomes 5 to the negative 1. And then in brackets, I still have n minus 1. So then what you want to do is multiply these two together. So you end up with 5 to the negative 9 equals to 5 to the negative n plus 1. Now you have 5s on both sides, so you can drop them, and you end up with that. And then if you had to go solve, you would eventually get that n is 10. Now you can use any of those 2 methods. You don't have to do both. Consider the geometric series where that expression is equal to 27 and the sum is equal to 26. Calculate the value of r. Okay, so here they're not saying that Tn is 27. They're saying that this entire expression is equal to 27. So they're saying that the sum to infinity is 27, and so we know that the sum to infinity formula is a over 1 minus r. So we could say a over 1 minus r is equal to 27. Because remember, this thing here stands for sum, and now they're just doing sum to infinity. And they're starting at a 1 over here, so there's no issues with the number of terms or anything like that. So there's our first equation. The next one, they tell us that the sum is 26. So the sum of a geometric goes like this. A and then 1 minus r to the n over 1 minus r. Or you could also do it as r to the n and then minus 1 over r minus 1. Remember that this minus 1 is not part of the exponent like we see in the Tn formula. Here they're together. Here they're not. Okay? So you can choose any of these 2 combinations. As long as the 1s are on top of each other and the r's on top of each other, the r's and then the 1s. It's as long as they on top of each other, that's perfect. Don't put the 1 on top of the r and the r on top of the 1. That's when, oh no, why am I raising that one as well? That's when problems are going to start happening. Right, now they tell us that the sum of 3 terms is 26. So we could say 26 equals, now it's the sum of 3 terms, so n is 3, and then like that. Right, now there's multiple ways we can do this. I'm going to get a by itself, so a is equal to 27 and then 1 minus r, because I just multiplied that up to the top there. Now I'm going to substitute this expression for a into here. So we end up with 26 equals to 27, 1 minus r, and then 1 minus r, 3, and then 1 minus r. So what we can now do is the 1 minus r's can cancel, and then we end up with 26 equals 27, 1 minus r, 3. And then there's multiple ways you could go from here. You could multiply the 27 in, or what I feel like doing is I'm going to divide by 27. So we're going to end up with 26 over 27 equals to 1 minus r3. Then I'm going to get the r3 on the left because I want it to be positive, and then I want this on the right. And then if you just type this on your calculator, it's 1 over 27. Now I can take the cube root on both sides, and that'll just give me 1 over 3. The lines y equals to x plus 1 and y equals to minus x plus 7 are the axes of symmetry of this function. So this function is a hyperbola, and we have learned that a hyperbola, for example, will have asymptotes like there and there, for example, and then they're going to have two parts, and then they've got these symmetry lines that go through this point like that, and they always have the same gradient. Well, not as each other, but this one always has a gradient of 1, and then this one always has a gradient of minus 1, always. And that's what they're saying. One of them has a gradient of 1, and one of them has a gradient of minus 1. And they're saying that it's the axes of symmetry. So they say, now remember that this part here is your vertical asymptote, the one that goes like this. And then this here is your horizontal asymptote, the one that goes like this. So this is your horizontal asymptote. So if I can take this equation, and I can take this equation, and I can make them equal to each other, that'll help me to find this little point in the middle here, right? Once I have that point, then I know the equations of these asymptotes. For example, if this point over here is 3 and 1, then I know that this x value is a 3, and I know that this y value is a 1. And then I could get my equations. But this is just an example, okay? So let's ignore that one now, and let's go make these two equations equal to each other. So x plus 1 equals to minus x minus 7. If I take this x over, I would end up with 2x. And if I bring this over to the right-hand side, I would end up with minus 8. And so if I solve for x, I end up with minus 4. Then to find the y value, I can just plug that x value into any of these equations. So I'm just going to use the first one, and so y is minus 3. So if I had to go draw these two, if I had to go draw x is minus 4, that would be somewhere, and then y is minus 3, that would be somewhere over here. So the dotted lines, the asymptotes would go through that point, and so this would be y is equal to minus 3, and this would be x equals to minus 4. So that now helps us to know what to do here. Be careful though. Can you see that the graph is 4 places to the left? So that actually means that here we're going to say x plus 4, not x minus 4. Because when you move left, it says plus, and when you move right, it means minus. And then this part here, this will be normal. So this means we've moved 3 places down, so you'll just say minus 3. So when you then go, or actually then we could say therefore, well, the equation is going to be f of x equals to minus 2 over x plus 4, and then q would be minus 3. So we can see then that p is 4 and q is minus 3, and that's exactly what they wanted us to show. Now it says calculate the x-intercept. To find an x-intercept, you make y0, and so you end up with this. Okay, now all you do here is you take this minus 3 to the other side, so you'd end up with 3 equals to minus 2 over x plus 4. Then I just want you to cross multiply, so you're going to multiply this up to the top, like that. Multiply the 3 in, and then take the 12 over to the other side, where it'll become negative 14. And so x would be equal to negative 14 over 3. So x is negative 14 over 3. They now want us to draw the graph. Okay, so we've learned, when we learned how to draw hyperbolas, we know that we need a asymptote, well, asymptotes, both of them. We've got them over here. We need an x-intercept. We've just found that over here. Now, what is 14 over 3? 14 over 3 is 4.66. So it's negative 4.66. So if this is negative 4, then it's on this side of the asymptote. So it's probably there. Okay, let's get rid of that. And then we still need a y-intercept now. So to find a y-intercept, you make x0. So where's our equation? Y equals to minus 2 over x plus 4 minus 3. Now, to find a y-intercept, you make x0, so 0. And so that's going to end up giving you negative a half, take away 3, which is then going to be negative 3.5. Negative 3.5. So that would be, if this is negative 3, then negative 3.5 would have to be a little bit lower down. So we can easily get the graph now. We know that it's in this quadrant and this quadrant. And so then you can just do something like this. That. And then like this. Whoops. Okay. And so let's just go fill this in. 0 and negative 3.5. And then this one was negative 14 over 3 and 0. And then here would fill in x equals to negative 4.
Okay, so sketched below are the graphs. Okay, so they give us the two equations. Fantastic. And it says calculate the coordinates of A and B. Guys, I'm going to fly through this one because this is really, it should be easy for most of you. Okay, so to find x-intercept, we make y equal to 0. So I'm going to make y equal to 0 of this equation. Let me just write it down. So 0. You can factorize this if you want. I'm going to quickly throw it into the quadratic formula. And you should get x equals to 4 or x equals to minus 2. Right, guys? Because these are the x-intercepts of the graph. Moving on to the next one. Determine, okay, this is very easy. Determine the coordinates of C. I'm just going to quickly race through this. We know that to find the turning point, you just say x equals to minus b over 2a. That's going to be minus 4 over 2 times minus 2, and that should give you a value of 1. So that's the x value over here, but we need the y value. To find the y value, you just plug it into the original equation. So we'll quickly go through that. And that should give us 18. Okay, and so there we have the coordinates of C, and we have the coordinates of the x-intercepts. And so that's going to be, this is literally an exam paper though, so you might get lucky in your exam paper. This was like 2018, I think, the final exam. So it's probably going to get more difficult now. They won't make it easy like this the whole way through. Definitely not. Okay, so we've done that. Right. So now it says write down the range. So the range is all the y values of the graph. And so we can see that the graph is able to go up to this maximum height over here. Okay, so it goes up to that height over there. That's a bit skew. Okay, and then it's able to go all the way down to minus infinity. So we could say that y is an element that goes all the way from positive 18 down to negative infinity with a round bracket. If you prefer to use set builder notation, you could say that x is any number that is bigger than negative infinity and smaller than or equal to 18. So you can also do it like that. They tell us that the graph, let me just erase all of this stuff here. The graph of h, okay, so h is another graph. So they're telling us that h is the graph of f after it has been moved left or right. Remember, that moves the graph left or right. And then this part here moves it up or down. Okay, so let's quickly show here that this moves it left or right. And this moves the graph upwards or downwards. And they say that that graph has a maximum value of 15 when x is equal to 2. This is pretty cool. So they're saying that this new graph has a maximum value when x is equal to 2 and y is equal to 15. So when x is equal to 2 and y is equal to 15, that's somewhere over here. So how did they go from this maximum to this maximum? What did they do? Well, they moved one place to the right, because it went from 1 to 2, and then they moved 3 places down, okay, because it went from 18 to 15. So it says determine the values of P and Q. Okay, so we can say then that h of x is the same as f after f has been moved 1 place to the right, so we show it like that, and 3 places down, so we do that. So we can say, therefore, P is equal to -1 and Q is equal to -3. 5.5. Oh, seriously, it's also an easy one. Determine the inverse for 2 marks. So to determine the inverse, we know that it's a 2-step process. So let's just write out the equation of G, which goes y equals to 2x plus 4. So to find the inverse, step 1, you must switch the x's and the y's around. There we go. And then what we do is we try to get the y value by itself again. So that's going to be x minus 4 equals to 2y. And then to get y alone, we're just going to divide everything by 2. And so that would be y equals to a half x minus 2. Okay, and so that will be the answer for this one over here. For which value, oh, this is quite decent. I know some students don't like these, so I'm glad we're going to practice this a little bit. It says, for which values of x is the inverse multiplied by the original equal to 0? They want to know, where is the original, so that's the straight line, multiplied by its inverse equal to 0? So you know that if I gave you 2 brackets like this and I said, where are they multiplied together, and where would that give me where would that give us a 0? Well, you guys would say that it's when x minus 1 is equal to 0, or it's where x plus 2 is equal to 0. So if you multiply these two together, where would that give you a 0? Well, it would either be where g of minus 1 is x is equal to 0, or g of x is equal to 0. Okay, so then it's quite easy. They're pretty much asking us where is the y value of the inverse equal to 0? So you can go to the equation of the inverse, which is this one over here, and you can make the y value equal to 0. So we make the y value 0. So we're going to say a half x is equal to 2. And then if you had to solve that, you're going to get that x must be equal to 4. Then we're going to take the original one and make that equal to 0. But we already know that the x-intercept for that one is -2. Okay, and so for which x values would it be? It is when x is equal to -2, or when x is equal to 4. There we go. I think this is going to be the one I was waiting for. Something that's very challenging. You know, they always have that in functions. There's always that one question that is going to be quite challenging. Okay, so here we go. If P, okay, so P is another graph now, is equal to F plus K, determine the values of K for which P and G will not intersect. Oh, this is good. Determine the values of K for which P and G will not intersect. Okay, guys. So here we have it. So they have told us that the graph of P is equal to the graph of F plus K. Now, when they say plus K, it doesn't mean they're moving the graph upwards. It might also mean downwards, because K might end up being a negative value. So P is the graph of F, and then they move it up or down. So P is either going to it's going to be the same graph that we can see, but it's going to be moved up or down. So for example, if it moves up like that, or it could move down. Okay. Now they would like to know what must the values of k be so that P and G, so G is this one, okay, P and G do not intersect. So can you guys visualize that? This parabola, if you keep moving it upwards, it will always intersect the straight line. It'll always intersect the straight line. However, if we move it down, then we could possibly move it so far down that it does this. Okay, so it could move that far down. So it never ever intersects the straight line. Okay, let's pretend that the straight line and the parabola are going to go into each other. Let's pretend that they are going to go into each other. So we say minus 2x squared plus 4x plus 16 plus k, because I'm using this new graph. And let's pretend that they do go into each other. Right? So we made them equal to each other. So we're trying to find out, where are they equal to each other? You guys are going to love this. Check this out. Then we're going to take everything to the one side and just pretend like life is good right now and we're just trying to solve everything. Make it equal to 0. Then we just simplify a little bit. So this will become 12 minus k. Fantastic. Okay, so life is great. We've done that. Now, what we are going to now do is we are going to tell this equation, equation, I would like to know all of the k values so that this equation does not have any answers. Because that means that we are finding the k values where these two lines or these two equations cannot be equal to each other. So we made them equal to each other, and then we told the equation, okay, now I want you to find all the k values so that this equation does not have an answer. Some of you might still be thinking, okay, but how do we do that, Kevin? How do we tell this equation that we don't want any answers? Well, remember, in grade 11, we used something called the discriminant, which is b squared minus 4ac. We know that if b squared minus 4ac is smaller than 0, then it's called no solution. And that is exactly what we want. We don't want this equation over here to have a solution because we don't want them to be able to intersect. So there should not be an answer. So we go take b squared minus 4ac now. So that will be, b would be 2, a would be minus 2, and then c would be 12 minus k. And we tell this equation that I want it to be smaller than 0 because that means no solution. And now we go solve. So it's going to be 4 minus, this will become positive 8, 12 minus k, smaller than 0. And then that's going to become 4 plus 96 minus 8k, smaller than 0. We're then going to keep the minus 8k over here, take the other numbers to the other side, which will become negative 100. And so what we now have is that minus 8k is smaller than negative 100. Now, I get questions about this, not on a daily basis, but I get this often. People are always like, Kevin, when you divide with a negative, do we change the inequality sign? Yes, we do. So if you had to go divide by minus 8, you're going to flip the sign, and then it's going to become minus 100 over minus 8. And so k must be bigger than 12.5. But that doesn't make sense. Okay, so this is going to be plus k. Okay, let's carry on. And then so this part over here should be a plus k. And that then means that 4 plus 96, this would be a plus, this would be a plus, and that would be minus 100. So this would be positive over here. And so k would be bigger than minus. Oh, but now we're not dividing by a negative. Woohoo! Woo! I was still a bit confused there. Now we're not dividing by a negative, so we don't have to change the sign. So k must be smaller than minus 12.5.
Given g of x is equal to 3 to the power of x, that is a exponential, write down the equation of the inverse. Okay, so we first say y equals to 3 to the x. To get inverse, you switch x and y around, and then you get y by itself again. So the thing we're looking for is y. You're going to say log. Now this is the base, so we keep that as the base, and then x. And there's the answer. So y equals to log 3x. It says here, point P lies on this graph over here. Then they say the graph of H is translated to form G. Write down the coordinates of P. Okay, this is really easy. Check this out. If H of X is that, then how do we make that into that? Well, all we can see is that here, you would have to put a plus 4 over here and a minus 2 over here. Let me explain. Because minus 4 plus 4 would become 0, so your x, there wouldn't be anything over here. And then this would also become a 0, so you wouldn't have anything down here. So what does that do to a graph? Well, because it's with the x, it moves it 4 places to the left, moves 4 left, and what does that do? Moves 2 down. So they're saying point P is on H. Then they're saying, what is point P going to become if you'd make it become this equation? So it just means that you're going to take point P and you're going to do this. You're going to move it 4 places to the left. So 6 will become 2. And 11 will then move 2 places down to become 9. Sketched is the graph 2 to the power of x plus p plus q. T is a point and the asymptote is y equals to negative 16. Determine the values of p and q. So we've learned with hyperbolas and exponentials that when you've got that p, that q, that is your asymptote. That is the asymptote. So if it's minus 16, then that means we can already go and fold that in as minus 16. Now, you see, this is actually just a y value. This is an x. So if we have a point, we can just go fold that in. So 16 is a y value. 3 plus p minus 16. Now it's just a matter of solving. So take this 16 over to the other side. It will become plus 16. So 16 plus 16 will be 32. Now here we can, if you are a grade 12 learner right now, you can use logs, but I'm just going to use more of a grade 11 approach where we're going to break this number down using shift fact, and that'll be 2 to the 5. It's the same as 32. Now, because these two are now the same, we can drop them, and then we end up with 5 equals to 3 plus p, and if you get p by itself, it'll be 5 minus 3, which is 2. So we found q as minus 16, and we found p as 2.
An amount of 10,000 Rand was invested for 4 years, earning interest at R%. So we don't know what the interest rate was, and we know that it was compounded quarterly. At the end of the 4 years, the total amount in the account was this. Now, grade 12 learners, so many of you make mistakes with these types of questions. The reason is, and I really have seen this a lot, it's because in grade 11, you get really good at financial maths. Then you start grade 12 and you learn about the future value and the present value formula. And then you sort of start forgetting about the grade 11 stuff. And then when they give you a question like this, you think, oh, it must be a future value, or oh, it's probably a present value. In fact, this is not a present value or a future value question. You need to be very careful about this. So a grade 11 financial maths question is typically like this. You start off with a certain amount of money, and then that money is going to grow to another amount. In grade 12, you would put maybe 500 Rand every month, but then you would do it every single month. You would make the same payment on a regular basis. That is how grade 12 financial maths works. But in grade 11 financial maths, it's more like this question over here. So we actually just going to use the formula A equals to P 1 plus I to the power of N. Question. Okay, so they tell us that it's going to get to 13,080. Okay, so we're going to go 13,080. That's your final amount. And then the starting amount is 10,000. And then the interest rate, we don't know what that is. So I'm just going to say R. But then I do know that it says that it's compounded quarterly. So that's a 4. And then remember that quarterly. So I'm sorry, it's 4 years. So we're going to say 4 times 4 over here. And so what I would do next is I would take this 10,000 Rand and I would divide it on the left. So that would give us 13,080 over 10,000. I'm not going to type anything in on the calculator just yet because I want the most accurate answer possible. And then 4 times 4 is 16. So some students often ask me here, they're like, Kevin, do I use logs now? The answer is no. Logs would work nicely if you didn't know what this one was. Like, let's say this was n. That's when you use logs. But we know what this is. It's a 16. So what we do is we take the 16th root on the left-hand side. Like that. And then what we now have on the right-hand side is that. Okay. I still won't type anything in on my calculator. I'm using a little hack over here. Otherwise, we have to round off, or we don't have to round off, but then, yeah, it's a lot of writing. So I just leave it just like that for now. The next step I would do is I would take this positive 1 over to the left-hand side. And so that's going to give us the following. Just don't put the 1 inside the root. It's on the outside, okay? And then we have R over 4. I'm still not going to type anything on the calculator. The next step, you would have to multiply the 4 over to the left. So what I would do then is I would put a bracket and I would multiply the 4 over to the left-hand side. And that is how I would get R by itself. Okay? And so if we had to go type all of that in on the calculator now, let's see what we get. And then do not round your answer off at this next point. You instantly are going to multiply with 100. You must multiply with 100 because we're trying to get the percentage. And so if you do this correctly, we do actually get 6,77%. So you cannot round off at any moment. Otherwise, the answer gets impacted quite badly. A businesswoman deposited 9,000 Rand into an account at the end of January 2014. She continued to make monthly deposits. Can you see this? That this is a grade 12 question because it says that she starts with 9,000 and then she continues to make monthly deposits of 9,000 Rand. So she makes the regular payment of the same amount. At the end of each month, up until the end of December 2018, the account earned interest at 7.5% compounded monthly. Calculate how much money is in the account immediately after she has made 60 deposits. Okay, so this one's very straightforward. They don't talk about anything fancy like she missed payments or she did anything weird. Everything seems straightforward here. And so it says calculate how much money was in the account. So do we want to know how much money was in the account when she opened the account? Or do we want to know how much money she has after 60 deposits? Well, she wants to know how much money she has at the end. So she wants to know how much money she has in the future. So we're going to use the future value formula, which I'm just going to write out over here for you guys. Okay, so that's your future value formula. Some curriculums like the IEB, you have a bigger bracket down here. That's absolutely fine. You can go with that. And so if we had to go work out the future value, we know that her monthly payment is 9,000 Rand. The interest rate is 7.5%. And it's compounded. Oh, by the way, You don't have to say 0,075. I know some students, they like to say 7.5 over 100. You can do it like that. I've just never done it that way, but I know a lot of students like to do it that way. And then over here, I would put a 12 because it's monthly. And then we know that there's going to be a total of 60 deposits. So I'll put a 60 over there. Okay. And so if I had to go work out the future value, you just go type all of this in. There we go. Okay, so we get an answer of 652,743 Rand and 95 cents if we round off. So this is the answer over here, 652,743.95. It tells us that this businesswoman, she left the amount calculated in the previous question, which I've added it over here for us. She leaves that amount of money. So she has 652,000 Rand and she just leaves it in the bank. Why would she do that? Because when you leave the money in the bank or in the investment account, it's obviously going to grow with a bit of interest, like compound interest. Okay. So the interest rate remains unchanged and no further payments were made. So this is not a grade 12 question now. This is now a grade 11 question because she's not adding any more money. She's just leaving the money and it's now going to grow and grow and grow. Just using normal compound interest like this one over here. Okay, now listen to this. It says that the total interest earned over the entire investment period, that includes the previous question, guys. That's the part that might confuse you. When I did this one earlier, I also had to read it a few times. It says that the total interest earned over the entire investment period is 190,000. Okay. Then it says determine the value of n. Right. So I need to make a little picture for you guys so you can get a nice idea of what's happening here. So what we have originally is this lady starts her investment once upon a time, and she invests money for 60 payments. That was what we did in the first question. So this is all first question. And this was for 60 payments. Okay. And how much did she pay every month? This was always 9,000 Rand per month. Okay. Then we get to this part at the end, and she's going to leave the money in the account now. So she's going to, let's draw another little arrow. She's going to leave the money in the account. We don't know how long she's going to leave the money in the account for. Okay. And then she's going to get to some ending point over here. Now, they tell us that, guys, why do people invest? What is the point? Do you just give the money to the bank and then they give you the same amount back? No, that would be stupid. If you just give money to the bank and then they give you the same amount back, you might as well just keep it at your house. The reason that we invest is we are going to earn interest. Interest is the extra money. So for example, if you put 500 Rand into an account and in 1 month it goes to 600 Rand, that means that you have earned 100 Rand interest. And it's the interest. That is why people invest, because you can take a 500 Rand, you can turn it into 600 without doing a lot of work. Okay. You just put it into the account and boom, it grows. Okay. So they tell us that this lady, she made 190,000 Rand in interest. So that's how much money she made extra. So that's how much money her investment made over over this entire period. She made 190,000 Rand. So what we need to go and do first is we need to go and calculate how much money or how much interest did she earn in the first 60 payments. Okay, now that's a very easy thing to do. I'll show you guys exactly what to do. Think about this carefully. She paid the bank or the investment brokerage, she paid them 9,000 Rand per month Every single month she did that. Imagine that. She goes there, she pays them 9,000 Rand. She did that every single month for 60 months. So how much of her own money did she actually spend over the 60-month period? Well, what you would say is 9,000. It's very easy, guys. 9,000 multiplied by 60. And let's see how much money she actually spent of her own. Okay, so she spent 540,000 Rand of her own money. But after the 60 payments, the person at the bank told her that she now has this much money. Ah, look at that, guys. She put in 540,000 Rand at the bank, but the total value became 652,000. Why is it more? Because of interest. Okay, so let's see. So the future value, we know that that was equal to 652,743 Rand and 95 cents. So how much interest did she earn for that period? Well, you would just minus those two values, right? So you'd say 652,473. Yeah, I totally just said the wrong numbers. 652,743.95 minus 540,000. And that gives us 112,000 Rand. Okay, so she made quite a nice amount of money. That is interest that the bank or the investment gave her. 112,000 Rand, 112,743 and 95 cents. Right. But we were told that this lady, in her total investing career, she actually made this amount of money. That is how much money she actually made. So we already know that for this piece over here, let me just get a highlighter quickly. For this piece over here, we know that she earned a total of 112,743 and 95. So we we also know that the total amount of interest earned was 190,000. So we could also now we could work out how much interest did she make in this period over here. So the interest for this little piece would have to be 190,214.14 minus the amount of interest that she earned in the first part. And if we had to go work that out, that means that she earned a total of 77,000 Rand or 77,470.19. That is how much interest she earned in this part over here. Okay. Okay. So we now know how much interest this lady earned over here. So what we can now do is we can now use this formula. Let's do that a little bit better. We can use this formula now, but now you've got to be careful. So we know that over here, the P, or the starting amount that she has there, is the amount that she earned from question one. So that's the 652,743.95. Let's get rid of some of these numbers. There's too many numbers right now. So that's how much money she started off with over here, right? Now, how much money would she have at the end? Well, of course, she started with this amount of money. She did not put any more money into the bank. So the only extra money that she earned was the interest, which we have over here. So we can work out her A value, which would now be 652,743.95 plus the extra interest that she just earned. Okay, and that becomes your A value. And if you work that out, you get about 730,214.14. So that is the total amount of money that she has here at the end. So that is A. So now we can use that grade 11 formula by saying 730,214.14 equals to the starting amount at that point, which is the 652,743.95. Okay. The interest rate is the previous question's interest rate, which I think was 7.5%. Yeah, 7.5%. I'm going to say 0.075. And it's still compounded monthly. Yeah, they said the interest rate remains unchanged. So that's still going to be monthly. And then it says determine the value of n. So we just put a little n over there. Okay, so notice that we have an n over here. So we're going to have to use logs, but not yet. What we're going to do first is we're going to take this amount here, and we're going to divide that on the left. By the way, I have mentioned this to you guys a long time ago. When you are calculating logs in financial maths, it is extremely sensitive to any rounding off that you are going to do from this part forwards. So from this part and afterwards, do not round off anything. Otherwise, it actually changes the answer quite a bit. Okay, I have spoken to you guys about this before. So don't round off at all. So what I like to do is I like to hack the system a bit. I don't type anything in on my calculator. So I just do this. I go 730, and then I divide that by 652,743.95. Fantastic. Then on the right hand side, I still have 1 plus 0.075 over 12 to the power of n. And now I am ready to go and do my log. Okay, so I'm just going to erase all of this stuff here. We know that n is now going to be equal to log, and then it's going to be whatever this number is. So I'm going to put that over here. And then over here, we're going to have this number. This is how logs work every single time in financial maths. It'll never not work like this. Okay, go type all of that stuff into the calculator. Looks like a mess, I know. And you should get a beautiful answer of 18. And you can almost guarantee in a test that when you get a nice answer like that, come on, you know it's right. So there we go. The answer is 18.
Determine the first derivative using first principles. First principles should be a automatic full marks for you. We've done so many of these examples, and there's only so many ways they can ask it. So this is that thing where you have to go use that long formula. Limit h goes to 0 of f of x plus h minus f of x over h. Now, before we start, what is the answer going to be? If you just take the first derivative using the FOST methods that we've learned, well, the answer should be 6x, because 2 multiplied by 3 is 6, and then you minus 1. So you must get this at the end. If you don't, you have done something wrong. Okay, so the formula says that we must take the limit as h goes to 0. Now, f of x plus h, all that means is you're just going to replace x with x plus h. So that's going to look like this. Okay. Then it says minus, and then you're going to minus f of x. Now, f of x, whoops, is just that. We don't need to use brackets in this one because that's only one term. But if it was like 3x squared plus 4, then I would definitely say use a bracket. And then at the bottom, h. Now, you got to keep writing this silly thing down. Limit h goes to 0. Now, I just want you to simplify. But a lot of learners start putting the 3 into the bracket. You can't do that until this 2 is gone. But then what other learners do is they just say, oh, that's just going to be x squared and h squared. No, you have to make 2 brackets. Or at least if you know how to multiply it without making the brackets, but just doing it in your head, that's also okay. But I advise putting the brackets down like that over h. And then write this all down. Okay, now what I like to do is I multiply these two together, and then I leave that answer in a bracket because we still need to take care of the 3. And then minus 3x squared over h. I'm going to carry on over here. So I'm going to multiply the 3 in now. So that's going to become 3x squared. Now here we have xh plus xh, which is 2xh. If we multiply that by 3, it will be 6xh plus 3h squared minus 3x squared. Now, what I've always told learners is at this step here, everything that does not have an h should cancel. If not, you've done something wrong. So you can see that this 3x squared is going to cancel with that 3x squared. And so there we go. Everything that did not have an h cancelled out. And so now we're going to say limit as h goes to 0. And now what we left with at the top is 6xh plus 3h squared over h. equals limit as h goes to 0. Take out an h as a common factor now, and then you're just left with 6x plus 3h. I know you could take out a common factor of 3, but for these like first principle questions, just take out an h. Because the only reason we're doing that is so that these h's can cancel. Now, we don't have an h in the denominator anymore, so we can let the h become 0. We couldn't let the h become 0 in any of these steps because the h in the denominator, you can't have a 0 in the denominator. But now we can just say equals 6x plus 3, and now I'm going to let h become 0, so I don't have to write this anymore. And then it just becomes 6x, like we said over there. In this question, they want us to take the first derivative, but they're not saying first principles or anything like that, so you can just do this fairly quickly. But before you go write out that, first simplify this and make it look something that can actually, we can take the derivative of. So x squared is fine, minus 3 is fine. This is not fine, so what we're going to do is bring it to the top, like that. Now we can go take the first derivative. So you multiply the 2 to the number in the front, which becomes 2. Then you subtract 1, so it just becomes a 1. This just falls away completely. And then this part over here, you're going to multiply the minus 2 and the 9. And then you're going to subtract 1 from here. So that actually becomes minus 3. Now that is the answer. Back in the day, a couple years ago, they never wanted us to allow the answer to have a negative exponent. So in those days, we would have to go and do one more step where we would have to take the x minus 3 to the bottom. But it looks like on memos and things like that is now changing. And so you can typically now just leave your answer like that. Here they want us to take the first derivative. So the first step is to go neaten all of this up first. You can't just go take the first derivative immediately. For learners that are doing AP maths, you guys might be like, yo, but I can just use the product rule. Yeah, I wouldn't do that. I would keep those techniques only for your AP maths, all right? So let's first go multiply this bracket out. So what is square root x multiplied by square root x? Well, it's the square root of x squared, but then the square root cancels out the 2, so it actually just becomes x. There is a rule. If you multiply the square root of two things that are exactly the same, the answer just becomes that thing. Okay? And then this multiplied by this is negative square root x. And then this multiplied by this is 3 square root x. And then 3 multiplied by minus 1 is that. Now, if we had to simplify this, you've got minus 1 square root x plus 3. So what is minus 1 plus 3? It's positive 2. There we go. Now, we're almost looking good. We just need to change this. We don't want to have a root. So we rather write it as x to the power of a half. And so now we can go and take the first derivative. So this just ends up becoming a 1. That just becomes 1. If you multiply these two together, that becomes 1. And then you have to subtract 1 from here. So this becomes negative a half. And then here, this just falls away. And so there's your answer.
It tells us that the graph is given, A and B are the turning points, determine the coordinates of A and B. So this is a nice, easy question. Why is this an easy question? Because we know that to find a turning point, which is these points over here and this point over here, we know that that is where the gradient of the graph is equal to 0. And we should know that if you want to find the turning point of a cubic graph, you must take the first derivative and then you make that equal to 0. Because I don't want to say too much. So we take we write down the original equation. Then we take the first derivative. I've had some students who call it the first derogative and some really interesting things. But it's the first derivative, and we take the first so we take the first derivative, and that's going to give us 6x squared plus 6x minus 12. Now, can you guys remember that the first derivative is it's just another name for gradient. So look at this point and look at this point. What is the gradient? The gradient is 0. So we say 0. And we then say 6x squared plus 6x minus 12. Now, you can solve this however you like. You could try factorize. You can use the quadratic formula. I think I'm going to try factorize. It looks like it will work. I'm going to divide everything by 6 plus x minus 2. And so what we do now is we can still factorize this one. This one will still factorize nicely as x plus 2 and x minus 1. And so therefore, x must be negative 2 or x must be equal to 1. And so this x value is 1. And then this x value is negative 2. Okay, but now we don't know what the y value is. Now, what a lot of students do, in order to find the y value, they plug it back into this equation. But then guess what you are going to get? You're just going to keep getting a y value of 0. And that's not what you want to do. Remember, you are looking for the y value. This is not a y value. That is a gradient value. So if you want to find a y value, you must come back to the original equation and plug it into that one. Okay. And so if we go plug in minus 2, so if we plug in minus 2, remember to always do it in brackets. Otherwise, you won't get the correct answer. Well, sometimes you will, but that's just luck. So I'm just going to quickly type that all in. Okay, and this y value should be 20. And then I'm going to quickly plug in the y value of 1, and that's minus 7. For which values of x will the graph be concave up? Okay, what we should know is that I'm going to give you guys a quick little summary. So look at the graph over here. What is the graph doing over there? Is it happy or is it sad? Well, that's a sad face if you ask me. Like if I put some eyes over here, you can sort of see this person is really sad. Okay, it's a terrible drawing, Kevin. Now, if you look at this side, this person is happy. See? Smiling. You can sort of see the smiley face over there. Right. So, did you know that the happy face is when the graph looks like this? And that is called concave up. And that is when the second derivative is bigger than 0. Okay, now some students struggle with these signs. So I'm going to say bigger than 0. Then you get the sad face area. So that's where the graph looks like a sad face. That's called concave down. And that is where the second derivative is smaller than 0. Smaller than 0. So here they're telling us for which values of x will the graph be concave up. So where is the graph concave up? Well, that's the smiley face. So it's going to be all of, it's going to be this entire area over here. Smiley face. Can you see it? That's where the graph is smiling. So how do we find that? Well, we take the second derivative. So let's quickly write out the original equation. So the original equation is 2x cubed plus 3x squared minus 12x. I'm going to switch my video off quickly because we're about to write down there. I'll be back. And then the first derivative, we already looked at, is 6x squared plus 6x. Oh, by the way, I know some of you are asking me. The question you may be thinking in your head is, Kevin, when we were solving the first derivative, we divided everything by 6. Can we use that when we go to the second derivative, or must we use this original one? Well, if you're thinking that, that's a good question. It's a question I get a lot. You have to use the original. You can't use the although it doesn't really make much of a difference, but I just like to advise learners to use the original. Okay, otherwise things can get a bit confusing. So just always come back to the original. And then if we take the second derivative, that's just going to give us 12x plus 6. Okay, 12x plus 6. Now, we would like to know where is the second derivative concave up. So that means we must do this. So we want to know where the second derivative is bigger than 0. So we want this to be bigger than 0. And now we solve. So we take the 12x and the 6 goes over, so it becomes a negative 6. Now, be careful. A lot of students, they always say, Kevin, I'm going to switch the sign because I'm dividing with a negative. Guys, you are not dividing with a negative right now. We are dividing with the number 12. That negative 6 has nothing to do with it. Okay, so we're not going to switch the sign over there at all. And so we're going to have 12x bigger than minus 6. And so if you had to divide that by 12, you're going to get negative a half. So it means that this graph will be concave up when x is bigger than negative a half. So that means that the x value of negative a half is probably over here. And all the x values that are bigger than that will be all of these x values. And that is where the graph is concave up. Okay. Determine the equation of the tangent. Determine the equation of the tangent at point C. Okay, so what is a tangent? Well, we know that a tangent is a line that is going to touch this, it's going to touch the graph over here at that single point, okay? So a tangent would look something like this, for example. Let me see if I can get this right first time. Oh, beautiful. A tangent is something like that, okay? So tangents are very easy to find, to be honest. It's very easy marks. We know that a tangent is a straight line, so it's y equals to mx plus c. Now, remember the following important thing. A tangent, or let's do this. The gradient of a tangent is the same as the gradient of the graph. The gradient of the tangent is the same as the gradient of the graph at the point of contact. Okay, so what we need to do is we need to work out what is the gradient of the cubic graph over there. Now, how do we find the gradient of a cubic graph? We use the first derivative, because I said earlier that the first derivative is another name for gradient. So once again, we're going to go find the first derivative. Once again, we can go find the first derivative, which we said earlier was 6x squared plus 6x minus 12. Are we going to make that equal to 0? No. The only reason we made it equal to 0 earlier was because we were looking for the turning point. And at the turning point, the gradient is 0. A lot of learners, they just want to put 0 over here. But you've got to ask yourself, why? Well, when do I put a 0 there? Okay, so we don't know what the gradient is at this point. But we do know that the x value is 2. So I can substitute an x value of 2 wherever I see x. And if I had to go work that out, we get 24. What does that mean? It means that the gradient is equal to 24 over here. The gradient is 24. Now remember that the gradient of the graph is the same as the gradient of the tangent. So the tangent gradient is also going to be 24. There we go. Now to find the c value, you can plug in any point that is on the tangent, but that point is this point over here. So we can plug in the 4 and the 2. So the 4 is a y value and the 2 is an x value. And now we just go solve for c, and I think we should get negative 44. So c is equal to negative 44. Let me write that nicely for us. And so the final answer for this equation is going to be y equals to 24x minus 44. The graph of f of x equals to that has 2 turning points. The following information is also given. Okay, guys, so let's go understand this very nicely. So this part over here, I want you to look at that and I want you to really think about what does that mean? It's telling you when x is 2, then the y value is 0. That is an x-intercept. That is a mathematical way to say x-intercept. We are also told that the x-axis is a tangent to the graph at x equals to -1. Okay, I'll show you what that means just now. We are also told that, notice here that they've got this line over here. That means, it does not mean the inverse, by the way. The inverse has a -1. That's inverse. This stands for first derivative. And what does the first derivative stand for again? The gradient. And so they're telling us that when x is 1, the gradient is equal to 0. When is the gradient 0? Well, that's normally when it's a turning point, right? If you have a graph like this, when the gradient is 0, it's a turning point, okay? Then they also tell us that when x is equal to a half, the gradient, because remember that's what that little line means, the gradient is positive, because it says that the gradient is bigger than 0. Okay, quite a weird question. It now says, without doing any calculations, draw a graph indicating all of the x coordinates, the x coordinate of the x-intercepts, and the turning points. Okay, so we got to take this information and we got to try get a nice graph. Now, you might not get it perfect. They might not give you enough information to get a perfect graph, but the teachers are going to be looking for specific things that you add to the graph. Okay, so we'll get our x and our y axis. And now we're literally just going to go fill in whatever we can. So they told us that when x is 2, y is 0. So when x is 2, y is 0. So that's going to be here. Perfect. Then it says when x is 1, the gradient is 0. Oh, wait, I forgot about this one. Let me get a highlighter quickly for you guys. Let's get a highlighter. Forgot about this one. Okay, so let's do that. So it says that the x-axis, now remember, this is the x-axis. Okay, they said that the x-axis is a tangent when x is -1. Okay, so when x is -1, that's about here. Then the x-axis is a tangent. How can the x-axis be a tangent? It's when it can only be a tangent if your graph is turning on the x-axis. Then it's a tangent. But it could go like that, but it could also go like that. And we don't really know which one it is just yet. So it could be any of those. Okay. They then say, okay, so that when x is 1, okay, so they also told us that when x is 1, the gradient is 0. Okay, so when x is 1, we have another turning point. But now, so x is 1 is somewhere over here. But we don't know where that turning point is. It's somewhere along this line. It's somewhere along the x equals to 1 line. But we don't know if it turns here or if it turns somewhere down here. Okay, so there is one extra thing they've told us. They said that when x is a half, so x is a half is somewhere along this line. When x is a half, the gradient is positive. Okay, so the gradient must be positive when x is a half. So what does a positive gradient mean? It means that it goes up like that. That's a positive gradient. And if it goes down, then it must be a negative gradient. So when x is a half, we have a positive gradient. So that means the graph is doing something like that, which then means that the turning point must be somewhere up at the top here when x is 1, and then it's going to go through like that. And then we then know that the graph is going to go like this, and then it's going to turn over here and like that. So they tell us that O is the center of a semicircle passing through A, B, C, and D. The radius of the circle is x minus x squared. Okay. The radius is x minus x squared. So I'm just going to fill that in quickly. There, so those would all be the radius. So this would be x minus x squared, and then x minus x squared, because those are all radii, right? Because, yeah, it's going from the center of the circle. Now, they would like us to determine the area of the shaded region. So the shaded region is this part over here, and they would like us to calculate the area of that. So it's quite an interesting question, because you might think, oh, well, this is easy. We can just see it as a semicircle. And then all that we need to do is we just need to minus this part, and we need to subtract this part, and then we need to subtract this part, and then you would have your answer. However, it's not that easy to determine what the area of, it's not that easy to find the area of this part and this part, right? So here's the trick with this question. What we need to identify is that this area over here, let me just make this nice and clear for you guys. This area over here, check this out. Because this is a 90 degree, that is the quarter of a circle. That is a quarter of a circle. Because a full circle is 360 degrees, so 90 degrees is a quarter. So what we can do is we can go work out the area of a full circle. Okay, so the area of a circle, we know is pi radius squared. And so that's going to be equal to pi multiplied by the radius, which is x minus x squared. And then that is to the power of 2. But now we would like a quarter circle. So a quarter circle would be equal to pi x minus x squared divided by 4. Okay, so that gives us the area. That gives us the area of this entire piece over here. That gives us all of that. And so all that we need to do now is we need to go and subtract the triangle. So we must now subtract the triangle. Okay, and so we know that the formula of a triangle is equal to half base times height. And so what we can then say is that that is going to be a half. Now the base, you can treat it as this one over here. So that's x minus x squared. X minus x squared. And then the height is this one over here, which is also x minus x squared. Okay. And then by minusing those two, we will then be left with this piece over here. Okay, and so we're going to go minus those. So I'm just going to say here that the shaded area will then be equal to the semicircle, the quarter circle, which is pi x minus x squared over 4, minus, I'm going to switch my video off now because we're getting close, minus a half x minus x squared, and then another x minus x squared. Actually, I'm going to write that as x minus x squared to the power of 2, because there's 2 of them. Okay, Now, what we can do is we just need, this is technically the answer, but what we want to do now is we just want to simplify that, okay? And so what I think we could say is that, can you identify that there is a common factor here of x minus x squared and x minus x squared, or to the power of 2? So we can take that out as a common factor. I'm just going to erase all of this now. And so I'm going to take that out as a common factor, and then we'll be left with pi over 4 minus a half. Okay. Now, what I'm going to do quickly is in this little block over here, I'm just going to take out, well, I'm going to get a common denominator. Now, that common denominator would be equal to 4. And so I'm going to leave this as it is for now. And then I'm going to get a common denominator, which would eventually give us pi minus 2 over 4. And so that's where they're getting this part over here. And then all that I need to do is go multiply these two brackets together, the x minus x2 and another x minus x2. X minus x2 and another x minus x2. And then the pi minus 2 over 4 can stay as it is. And so that's going to give us x squared minus 2x to the power of 3. Sorry. Yeah, that's correct. Plus x to the power of 4. And then over here we have pi minus 2 over 4. And there is our answer. Of course, we could arrange this a little bit if we wanted to. We could move the x4 to the left. So here's the next part of this question. And this over here is the previous answer that we've just got, because we're going to have to use that in this part of the question as well. So it says here, determine the value of x, which will allow the shaded area to be a maximum. Okay, so whenever they ask us for a minimum and a maximum, we know that that is when the first derivative is equal to 0. Okay, now what are we trying to find the first derivative? What are we trying to find the maximum? We're trying to find the maximum area. So we need to have a formula for the area. And luckily we do. It's this one over here. So I'm quickly going to write that down again for us. So the area, I'm just going to call that A. A for area is equal to pi minus 2 over 4 multiplied by x4 minus 2x cubed plus x squared. Okay. Now, to find the maximum, we said that we need to take the first derivative. So we're going to take the first derivative of the area. Now, be careful, guys. You can't say A with a little line over there, because I know that you want to do that because this one has a line over there, but that's only when you, that's only because there's like that little X over there. But what we have is just A. Okay, so what we're going to say is that the derivative of A with respect to the variable X. Now, guys, if you get that part wrong in the exam, they probably won't do anything. They might take away 1 mark, but it's not something you need to lose sleep about. It's really not that important. Then we can now say, yeah, we don't need to do anything with this part over here. That's just a constant. Okay, so I'm just going to leave that in the front for now, because that's just a constant, right? The number pi minus 2 over 4, that's just a number. It's not a variable. So I don't need to take any derivatives of that. And then I'm going to take the derivative of this part over here, which will be 4x cubed minus 6x plus 2x. Sorry, that's a 6x squared. So that's 4x cubed minus 6x squared plus 2x. And I know that I want to make my first derivative equal to 0, so I make it equal to 0. Now, because this part over here is just a number, I can actually just divide that on the other side. You know what I mean? Like if it was like 0 equals to 2x squared minus 2x minus 1, we can just get rid of that 2. We don't need it. It's just going to make things a bit more weird. So we're just going to get rid of it. And so we're going to end up now with 0 is equal to 4x cubed minus 6x squared plus 2x. Okay, and now we just solve this however we need to. So for example, we can take out a common factor of x. And then you'd be left with 4x squared minus 6x plus 2. And so we can say, therefore, x must be equal to 0. Or we can say 4x squared minus 6x plus 2 must be equal to 0. And that we can just solve using the quadratic formula, or you can try to factorize that one. If you do that, I'm not going to go through all those steps. That's quite easy for you guys. If you had to go and factorize that, you should end up with x equals to 1 or x equals to a half. And then we also have this x equals to 0. So I'm just going to go write it there. X equals to 0. So the final answer for this question is x equals to a half. If you wanted to, you can also say x equals to 0, 5, whichever one you guys prefer.
Two events A and B are such that events A and B are independent. Independent is like a formula. It goes like this. This is called the independent formula. There we go. If two events are independent, we can say that. P of not A is 0.4, and then P of B is 0.3. So what we can go and do now is we're trying to calculate that. So we know what P of B is. If they say P of not A is 0.4, so not A is 0.4, so then A would be 0.6. So we can just say 0.6, and then P of B is 0.3. And so if you had to multiply these two, you would end up with 0.18. And just coming back to this not A, if I say, for example, that the probability that someone does not do maths lit is 40%, then the probability that they do maths lit would just be 60%. But when you're busy with decimals, decimals always add up to 1. So if the probability of someone not doing A is 0.4, then 1 minus 0.4 is 0.6. So the probability that they are in A would be 0.6. And that's how I got that. A survey was conducted among 150 learners. Okay, so there's 150 people. The following observations were made. The probability that a learner selected at random will take place in only hockey is 0.24. Only hockey. There we see it. Hockey and debating, but not chess. Okay, so that's where the hockey and the debating circle would overlap, but then it's not chess. So here's where the hockey and debating overlap, but they don't want all of that. They said and not chess, so they don't want the chess to be part of it, and that's where they got the 0.14. And then debating and chess, there. Okay, so all of that's shown. Now it says the probability that a learner selected at random participates in at least one activity is 0.7. So in at least one activity. So that would be the people who do only hockey, only chess, only debating, but it can also be the people who do all three and both. So it's all of these people. Can we agree that all of these people participate in at least one activity? Right? Some of them do 2, some of them do 3 activities, but they at least do 1. So they're telling us that all of that adds up to 0.7. So then we know that probability adds up to 1. So then we could work out the value of, okay, I don't know why I'm going so far ahead right now when we haven't even read the questions. Okay, I'm sorry. Let's just quickly see something. 15 learners participate in all 3. The number of learners, da-da-da-da-da-da-da-da. Okay, let's actually go do the questions now, Kev. Determine A, which is the probability that a learner participates in all 3. Now, don't go put a 15 over there because of what we read. It's 15 learners out of the total, which is 0.1. We can see that they're using probabilities here, so we can put 0.1. There we go. Now, determine M. Now, here we go. Here we can work out this value. We know that all of this is 0.7, and we know that probability adds up to 1. So if you say 1 minus 0.7, you would get 0.3. So M would be 0.3. Now it says how many learners only play chess. Okay, they tell us something interesting here. The number of learners that participate only in debating is the same as the learners who participate only in chess. Oh, okay. So we can't really say B is B. That's not really helpful. So how many learners play only chess? So they want to pretty much know, what is B? Well, remember what we said. We said that all of this adds up to 0.7. So we could say 0.24 plus 0.14 plus 0.1 plus 0.02. So I just added up all of those. Plus, so we've done this one, plus B, plus 0.12, plus B must add up to 0.7 because they said. So now we can just go solve for B. So I'm going to add all of these numbers together, okay? And so that would be 0.62, and then we've got plus B, so that's plus 2B equals 0.7. So then 2B is equal to 0.7 minus 0.62, which is 0.08. Divide both sides by 2, and we get B as 0.04. So B is 0.04. So they said how many learners play chess? Only chess. So only chess is just this part. So it's 0.04 of the 150. So you multiply 0.04 with 150. So 0.04 multiplied by 150, and that is 6 people. So 6 people play only chess. A 3-digit number is made up by using 3 randomly selected digits from 0 to 9. No digit may be repeated. Okay, so we've got these numbers available to choose from. Now, no digit may be repeated. The first question says, determine the total number of 3-digit numbers greater than 100. Okay, so think about this. We could make numbers like 105, 211. Oh no, not 211, because the number 1 isn't allowed to be repeated. 214, 986. You can't start with a 0, because if you had a number like that, it would be less than 100. Okay, so which numbers could we use then for position 1? Well, you could use the number 1, 2, 3, 4, 5, 6, 7, 8, or 9. So how many options is that? That is 9 different options, because there's 10 numbers here, and you just can't use this one. So let's pretend what we used. Or let's try guess what we used. Let's say for our first number, well, this is just an example code, an example. Let's say we used the number 3. Okay, so the 3 is now gone. You might say, Kevin, didn't we choose 9 as our first number? No, that's a common problem that learners have with this chapter. When you're getting your answers, we're looking at how many different numbers could we have chosen. We could have chosen any one of those except the 0, so there were 9 options. But let's pretend that we chose the 3 as our number, okay? Just as an example code that we're making. Now, for the next option, we could choose, here are some example codes: 304, 310, 326, 358. So you could actually choose 0 or any number, but we just can't choose a 3 because we've already chosen a 3 and no digit may be repeated. So how many options are there? Well, there's still going to be 9 because now we can use a 0. Now for our example code, let's say we used a 4. Okay, so then, let's say we used a 6. So we've used a 6. So now for the next one, how many options do we still have? 1, 2, 3, 4, 5, 6, 7, 8. Now if you had to go multiply, and we said we used let's say we used a 9. Okay, so there's the number that we made, but this number that we're going to get here is the total number of numbers, 648. So this is where learners get confused. We've just made one example over here, but they're telling us from this is that you could have made 648 different examples. That is how many codes you could have made. This is just one of those examples. Determine the total number of possible 3-digit numbers, both even and greater than 600, that can be formed. Okay, so we want the number to be greater than 600 and it must be even. So it could be codes like 624, 708, 912, 146. Notice that the last digit has to be even for the whole number to be considered even. Notice that the first number must be 6 or more so that it's larger than 600. Okay, so those are our restrictions. So we've got three places. We've got the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Let's start with our restrictions. We know that this number must be 6 or more. This number must be even. Now, there is a little bit of a problem because if we choose an even number over here, like 6, the number 6 or 8, because it has to be 6 or more, then this number here, we're going to have less options available for this even number. But if we choose an odd number over here, like a 7 or a 9, then we've got more options available over here. So we've got two scenarios that we have to do, okay? We've got scenario 1. Let's choose an even number for this first one as well. And then scenario 2, where it's going to be 6 or more, but let's choose an odd number for that one. And then this one still has to be an even number. So for scenario 1, how many options do we have for this first position? Well, it has to be a number that is 6 or more, and it must be even. So that could be a 6 or an 8. So we have two possibilities. Now, don't do this one yet. You do this one last. You always do your restrictions first. So how many even numbers do we have available if the first number was already even? So maybe we chose an 8 for this first one, okay? Because remember we said we could choose a 6 or an 8. So let's say we chose the 8. Now, how many even numbers do we have available? 1, 2, 3, 4. So there are 4 even numbers available, okay? Let's say we chose a 2. So how many numbers do we now have available for this last one? 1, 2, 3, 4, 5, 6, 7, 8. There we go. Let's now reset. Okay. Now for this scenario, let's say we chose an odd number for the first one. So it has to be larger than 6, or 6 or larger. So the only options are 7 and 9. So let's say we chose the 9. So you don't put a 9 over here. No. How many options did we have? We had 2. Now for this part over here, because the first number was odd, how many even numbers do we now have? Well, now we have 1, 2, 3, 4, 5. So let's say we chose a 2. So now for this part over here, how many options do we have? Well, there you would have 8. So if you had to work out this part, it's 64. And if you had to work out this part, it's 80. So to get your final answer, you add those up, which is then 144.